Consider a Cobb-Douglas production function y equal a k to the power theta n to the power 1 minus theta with a equal 200, n equals 100, theta equals 0.25. Further, the nominal interest rate is 8%, the rate of inflation is 3%, the depreciation is 11%, output sells for $100, and the price of a unit of capital is $50,000. The first part of the question is, what is the real price of capital? So, in order to get the real price of capital, it will be our nominal price of capital divided by the price. So here, our nominal price of capital is 50,000 divided by a price of 100. This will give us 500. The next part of the question is, what is the marginal cost of capital? So we need to differentiate between the nominal and the real. So the nominal marginal cost of capital will be the nominal price of capital multiplied by the nominal interest rate minus inflation rate. And we know that the nominal interest rate minus inflation rate will give us the real interest rate. Because nominal rate, it shows us how much our money will grow with. Inflation rate, how much the prices will grow with. And then the difference will tell us what will be the change in our purchasing power parity. The change in our purchasing capacity. We add depreciation because we have capital and we cannot use the same asset forever. It will depreciate by a certain percentage every year. So let's substitute here. So we have a nominal price of capital of 50,000 multiplied by nominal interest rate of 8% minus inflation rate of 3% plus depreciation rate of 11%. This will give us 8,000. Let's calculate marginal cost for real values. So it will be the real price of capital, which we calculated earlier, equivalent to 500, multiplied by nominal interest rate of 8% minus inflation rate of 3% plus depreciation rate of 11%. This will give us 80. The next part of the question. What is the optimal amount of capital that maximizes firm's profit, which is K star? So we know that our profit maximization is our marginal product of capital should equal to marginal cost. In the previous point, we said that our real marginal cost is equal to 80. So I know that MBK should equal to MC should equal to 80. Then I need to calculate MBK, our marginal product of capital. So we need to get the first derivative of our Cobb-Douglas production function. So I need to take the power of K and I put it down. So here it will be equal to theta multiplied by A. I need to put all the constant multiplied by n to the power 1 minus theta. Then I will get our variable, which is K, to the power theta, and I need to subtract 1 from the power. So what we need to do is, I need to put K in one side, all other variables on the other side. So I will divide both sides by this part. So I will say here, K to the power theta minus 1 is equal to MPK divided by theta multiplied by A multiplied by n to the power 1 minus theta. Here I have K to the power theta minus 1, but I would like to have only K to the power 1, not to the power theta minus 1. So I need to multiply the power here by 1 over theta minus 1. So I need to do the same with the other side. I need to multiply it by 1 over theta minus 1. So this part will offset this part. So this will give us K is equivalent to MBK divided by theta A n to the power 1 minus theta. All of this to the power 1 over theta minus 1. So let's substitute for K. So I know that K star here is equal to, what's our MBK? It's equal to 80 because it's equivalent to marginal cost divided by, what's our theta in the question? It's 0.25 multiplied by, what's our A? 200 multiplied by, what's our N? 100 to the power 1 minus theta is 0.25. All of this to the power 1 over theta 0.25 minus 1. If you calculate it, you will get K star is equivalent to 53.44. So this is the amount of capital that will maximize our profit. The next part of the question. Draw a graph of the MPK MC that includes the solution from the previous point C. So we'll draw here our x-axis, which is capital, our y-axis, which is marginal product of capital, MBK, and this will be our curve. Then we have our marginal cost, which is intersect with the curve. It will give us this point, which will be our capital. So we know that in this example, our marginal cost is 80. Therefore, our capital that will maximize our profit will be 53.44, which we calculated. The next part of the question is, include on the graph the impact of a decrease in the depreciation rate. In what direction does K star change? Is a new MPK higher or lower? So I want you to think about it before we calculate it. What do you think? What will be the impact of decreasing depreciation rate? So if we decrease depreciation rate, what will happen? Our maintenance cost will be lower. Here I refer to maintenance cost will be lower. Consequently, our capital will be higher. So before we calculate it, we know that K will be higher. So I will use the formulas that we used earlier. So I will assume that now the depreciation rate is 8% instead of 11%. Then I know that our marginal cost in real terms, it will be our real price of capital multiplied by nominal interest rate minus inflation rate plus the new depreciation rate. So it will be 500 multiplied by nominal interest rate of 8% minus inflation rate of 3% plus new depreciation rate of 8%. This will give us marginal cost equal to 65. Do you remember the formula for K when we rearranged the formula of MBK? So I would say here, K is equal to MBK divided by theta multiplied by A multiplied by N to the power 1 minus theta. All of this to the power 1 over theta minus 1. Let's substitute. Our new MBK is 65. We have the same theta of 0.25, same A 200, same N 100 to the power 1 minus theta of 1 minus 0.25. All of this to the power 1 over 0.25 minus 1. This will give us K equal to 70.48, which is higher. So let's show it in the graph. Now we have a lower marginal cost, which is 65. So we'll draw a horizontal line. It will intersect with our curve. So this will give us our new capital, K2 star, which is 70.48. So we know that when we decrease depreciation rate, it resulted in higher capital. The last point of the question is the lower depreciation rate good or bad for the economy? Briefly discuss your answer. So, as we explained in the previous point, lower depreciation rate, it means lower maintenance cost. Consequently, our capital will be higher. If capital increases, it would result in a higher output.